Differential equations. So normally differential equation is nothing but equation involving the derivative of the dependent variable with respect to the independent variable is called as a differential equation. Means here dv by dt, whenever you are dropping a solid into the water tank of the water, so it is moving due to the gravitational force. When you are dropping it, it is moving with the gravitational force. The change of the speed means velocity will be denoted by the dv by dt. And whatever the dv by dt v we are taking here, that is called dependent variable. And whatever t you are taking here, it is called as a
X is denoted
okay.
by.
Did you get my point? Can you hear me?
Yes, sir.
Yes, sir.
So here such type of the equations, normally we are going to have the equations as a trigonometric equations, in which the trigonometric functions are there. We call it as a trigonometric equation. Like that here differential equation is nothing but in that derivative of the one independent dependent variable will be there. So usually we denote the dy by dx by the y dash, and d square by double derivative of the 2 times derivative when you are doing it is denoted by y double dash, and 3 times derivative means y triple dash, and n times derivative of that function y with respect to x is denoted by y suffix n. Y suffix n means down n will be shown to you. So now here classifying the differential equations. Suppose if you are taking the differential equations, now x into dy by dx whole square plus 6y is equals to 0 is a one differential equation. Okay, now here finding the order and degree. The first thing is that most of the students will get confused to find out the order and degree. Degree should be based on the order. So degree, first you need to know that what is meant by order of the differential equation. Okay, and first thing is that you need to, whenever you are observing that three functions whichever it is highlighted in the blue color, x into dy by dx plus 6y is given to you, and d cube y by dx cube whole square, d square y by dx square whole cube, like that it is given to you. But when you observe the last two functions, sine function is given to you, inside the function is given to you differential equation. Okay, so these two are completely second one. We can determine the order and degree of the polynomial equations only. Means the polynomial equation, it should be a polynomial in a differential form. Means differentiation of the one independent variable with respect to the dependent variable with respect to the independent variable should be there. Here d cube by dx cube, it is a polynomial. The order is degree here, order is 3 here in this situation. Okay, and d square y by dx square, if you are taking into consider here, d square y by dx square whole cube plus 4y is equals to 3 is given to you in this situation. Are you getting my point here? So when you consider here, this is a polynomial equation. The degree of the polynomial equation is the degree of the highest order derivative of the differential equation. Degree is nothing but highest order, whatever you are having. The degree of the polynomial equation is the degree of the highest power. Means highest derivative, whatever it is there, that is highest derivative will be taken as a order, highest derivative. Because in this function, whenever you are observing that the highest derivative you are having 3 times derivative. So d cube y by dx cube, you are going to have the highest derivative. So this is the highest derivative you are going to have here. So that's why the order is 3 here. And that this highest derivative power, whatever you are having, highest power. Suppose if you are having d cube y by dx cube whole cube, then the order is degree is 3. So that equation is the third order second degree differential equation. We call this as a third order. That 3 is not taken from the second term. It is not taken from the second term. The order 3 is taken. When you observe this one, Is it a polynomial equation in terms of the differentials dy by dx? Whenever you consider that, because we are going to have the tan dy by dx, you are having tan, it is given to you. So tan dy by dx is cannot be said no. Second one, whenever you are observing the differential equation with the first order and second degree. Third one, whenever already we have discussed that third order, that is the third order second degree, and first order differential equation, this is the first order first degree differential equation. But the order and degree is defined of a differential equation is always positive integer. It should not be a negative integers. Okay, did you get my point? What is meant by order and what is meant by degree? So now we are going to learn how do we find out the solution of the differential equation. There are different methods to find out the solutions of the differential equation. So the first method, we are going to have the variable separable method. Okay, and before going to that, what is mean by a solution? Means dy by dx is equals to e power x minus 4 is given to you. What value of the y, what function of the y will satisfies the this one is called the solution of the differential equation. Means whenever you are taking it as a y as a e power x minus 4x plus 3, we are going to get it as a differential equation. Means you find the derivative of the function, you are going to get e power x minus 4. Even in the place of the plus 3, if you take any other number also 0, because the constant we are going to get it as the derivative of the constant is 0. So in the place of the 3, if you take any other number also, it gives you the solution as a e power x minus 4 only, the value we are going to. The value of the variable, means variable not, the function which satisfies the given equation is called the solution. The solution of the differential equation is the function that satisfies it. Means y function, what it satisfies, it is called the different solution. So in this situation, e power x minus 4x plus 3 is the solution of the differential equation. Not only plus 3, you may write there in the place of the 330 or any other number also. So there exist the two types of the solutions of a differential equations. One is general solution, another one is particular solution. What is meant by a general solution is nothing but, now whenever you are going to take the, in the place of the plus 3, if you are taking, it will satisfy. In the place of the 3, if you take the 5, it satisfies. Minus 5, it satisfies. Plus 122, it satisfies. So any number can be taken. It means the function can be varying. Here the function is changing. So in that situation, dy by dx is equals to, in all the situations, e power x minus 4 only we are going to get. So y, in that place, the constant c will be taken into consider, which is called e power x minus 4x plus c. E power x minus 4x plus c. These plus c, whenever you are taking, we call it as a general solution. We call it as a general solution, and particular solution also we are going to have. So in case the numbers, if you are taking, we call it as a particular solution. Building a differential equation whose general solution is given. Suppose if one function general solution is given, is corresponding differential equation, if you want to build up, what to do? Xy is equals to ax square plus bx is given to you as a equation. It is not given to you as a y is equals to something, but it is given to you as a xy is equals to ax square plus b by x is given to you. And here in this situation, a and b are the constant. To find the differential equation, the solution is differentiated to extent to that constants are eliminated. We need to eliminate the constants. So first, whenever you are taking this, you multiply the here. When you multiply here x square, x on both sides, x square y is equals to ax cube plus b, we are going to get it. Both sides x is multiplied. When both sides x is multiplied, we are going to get it as a x square. Now you try to do the differentiating this with respect to x. So first uv method is used left hand side, then right hand side b is eliminated, 0. So 3a square we are going to get it. And in the same way, when you are finding the eliminating the A also, that arbitrary constant, we call them as a arbitrary constants, and that arbitrary constants when you are eliminating, we are going to get it as a differential equations. And whatever the equation you are getting here, you differentiate here, we are going to get it x dy by dx plus 2y is equal to 3ax, and differentiating this also with respect to x again, this you differentiate with respect to x again, we are going to get x d square y by dx square plus 3 dy by dx is equals to 3a, and this 3a is equals to whatever you are getting, that you substitute in the second equation, this you substitute in the first equation. So therefore the a is eliminated and completely the equation is transformed into the dy by dx d square y by dx square, like that, and x only. So that equation is called as a differential equation. Now this differential equation will satisfy the function, means the solution of this differential equation is the given question. This differential equation is x square d square y by dx square plus 2x into dy by dx minus 2y is equal to 0. Its solution is what? The first question, given question. When the solution is given to you and we are finding the differential equation. So working rules to form the differential equation. So what are the working rules means? Observe the number of arbitrary constants present in the given general solution and find the derivative up to the order based on the number of constants. If two arbitrary constants are there, 2 times derivative should be done. As an example, when you see that only in this x square equal to 4ay, one constant is there, and you need to do the one time derivative, so that will be eliminated. And when you see that second example, x square by b square plus y square by a square is equals to 1, here two arbitrary constants are there, a and b. So 2 times derivative you need to do. The required differential equation order will become the 2. And next eliminate that arbitrary constants. And sometimes the equations may be given to you. So xy is equals to c e power x plus b e power minus x plus x square. Differentiating this one on both sides, we are going to directly eliminate and resubstituting that. Whatever we are going to get, we need to resubstitute that from the given equation. We are going to get the differential equation. Sometimes here in this situation you see here, what is done here? First time derivative will not be eliminated. Second time derivative will not be eliminated. So if you not eliminating is nothing but we are not supposed to continue like that. What we need to do here? We need to resubstitute that value. See, when you are doing the 2 times derivative, at the value, the function we are going to get c e power x plus b e power minus x, which is there already in the given solution. That value will be equals to xy minus x square from the first given equation. So that should be substituted in that place. So when you are substituting xy is equals to c e power x plus b e power minus x, we are going to get the differential equation. Differential equations are used to depict some geometrical properties of the curves. When you are taking here x plus dy by dx is equals to 0, x plus dy by dx is equals to 0 here. Differential equations, family of curves, we call it as a family of curves. So x plus dy by dx, equation of the circle with the center at the origin is x square plus y square is equals to r square. X square plus y square is equals to r square. So when you are differentiating this with respect to x, we are going to get 2x plus 2y dy by dx equal to 0. From this x plus dy by dx equal to 0. That is nothing but x square plus y square is equal to r square is the equation of the circle with a radius r. So when you are taking here x dy by dx, x dx is equals to minus y dy. So understand how the differential equation represents the family of circles. So now if you are integrating on both sides, this one, x square by 2 plus y square by 2 is equals to c, some constant we are going to get. So x square is equals to minus y square plus 2c1 we are going to get. and x square plus y square equal to c. 2c1 is replaced with the c. So we are going to get that x square plus y square equal to some constant, and that constant is belongs to the set of the real numbers, and it can be the any real number. So depending upon the real number is going to take, and the circle is going to get the different circles. So that's why we call it as a family of circles. So forming the differential equation for the family of parabolas. Family of parabola means only not a single parabola, for any curves in general form. So equation of the parabolas, whenever you are taking x square equal to 4ay is the general equation of the parabola, which is symmetrical about the y-axis. If it is symmetrical about the x-axis means y square equal to 4ax we are going to get. The given equation is symmetrical about the y-axis. That's why we call it as a x square equal to 4ay. So when you take x square equal to 4ay, differentiating with respect to x on both sides, we will get it as a 2x equal to 4a into dy by dx. Now rearranging these terms in the place of the 4a, you have to write 2x into dx by dy we are going to get. The 4a you replace by 2x into dx by dy. So we are going to get x square equal to 2x into dx by dy into y. From this x square into dy by dx is equals to 2xy. And x is both sides cancelled, and x dy by dx equal to 2y we are going to get. So this is the differential equation with the first order and first degree. So how the differential equation family of parabolas, how it represents the family of parabolas means when you are taking the dx to the right hand side and taking the same variables one side, y and x variables one side, and differentiating on both sides, sorry, integrating on both sides, log y is equals to log x plus log c we are going to get. From this, y is equals to x square plus c we are going to get it. Y is equals to x square plus c. So that is nothing but x square c we are going to get it. Okay. So from this y is equal to cx square we'll get. Y is equal to cx square is nothing but x square equal to some constant, whatever it may, 1 by c we are going to get 1 by c into y. X square equal to some constant into y. So for different constant, 4a value is going to change. So for different constants, we are going to get the different parabola. So that's why the family of parabolas we are going to get it. Okay, so differential equation with the one constant whenever you are taking, see that the equation representing the family of curves with the one unknown parameter, the differential equations with the two constants whenever you differential equations with the two constants will be two variables will be there. So differentiating this with respect to x on both sides, we are going to get it in the form of the another function in which x will be their variable, y will be there, and dy by dx will be there, and constant a is equals to 0 we are going to get. Some a will be eliminated. So eliminating a, actually what you need to understand first, left hand side concentrate. Given equation is going to have the x, y, a, any constant. Okay, so now when you are differentiating, a will be there as it is, x, y, and differentiating with respect to x means y dash extra we are going to get it, and a will be there. And a, if you are eliminating from 1 and 2 equations, you are going to get an equation in which only x, y, and dy by dx we are going to get, which is called differential equation. In the same way, two constants whenever you take, two times we need to do the differentiation. Then after eliminating a and b in any way, we are going to get an equation in terms of x, y. Actually here it is given that eliminating a and b means, in this one small mistake is there. Try to identify f of, fourth point you see here, f of x comma y dash comma y double dash should be given, but it is given to you a comma b. Did you get my point here?
Yes, sir. Yes, sir.
So A comma B will not be there. After eliminating A and B will not be there, and we are going to have the Y and Y dash we are going to have. Okay. So this is the thing you need to remember. So eliminating, the procedure of eliminating here it is given to you. So the number of unknown parameters determines the order of the differential equation. Two unknown parameters means unknown quantities are there means second order differential equation we will get. If the number of unknowns parameters present in the equation corresponding to the family of curves is 2, then the order of the differential equation is should be obtained 2. So this point you need to concentrate here when you are a differential. And this variable separable method, solution finding of the differential equation. So differential equation whenever it is given to you, now till now we have solution. If it is given, we formed the differential equation. Now if differential equation is given, how do we get the solution of that we are going to learn. Did you get my point? Now till now any equation is given to you, just like x square plus y square equal to x square equal to 4ay, or 4 y square equal to 4ax, like that. If it is solution is given to you, we formed the differential equation. Now differential equation is given to you, and how do we get the solution? To get the solution we are going to have the different methods. So one is, when you take into the consider these different methods, we are going to have the dy by dx is equals to the differential equation. Dy by dx is equals to f of x comma y. This is the means the function will be represented as a dy by dx into, and whatever the function is given to you, you need to write that function as a all the y terms together and x terms together, and you need to separate them. If it is not in that form, we are going to get the another different form. If it is in this form, we are going to move it into the variable separable. Means if it is possible to you to make as a two functions, separate functions. Suppose if you are having sin xy, in the brackets xy is given to you, such type of the problems will be discussed later. Now variable separable method we see here. Variable separable method means when you see this one dy by dx, we are going to have 1 plus y square by 1 plus x into x plus xy. Can you make it this into the form of the, see, this can be written as 1 by 1 plus x into x plus 1 plus y square by y square. So this is function in terms of x. Second one is function in terms of y, because we have separated x function separately and y function separately. So if it is possible to do like that, we can apply that variable separable method. So, and in this variable separable method, wherever the function in terms of x is there, towards that side the dx should be there. Means the completely y function should be transformed to the left hand side, so that y by 1 plus y square dy we will get, and dx will be there. So dx and dy compulsorily should be on the numerators, and integrating on both sides now. The right answer, whatever it is given to you, integration methods, different integration methods you have learned. How do we learn? So what method that one? Partial fraction.
Partial fraction, sir.
Yes, very good. Partial fractions. Applying the partial fractions, we are going to get into the, because that is a one method. Different methods can be used. What you have learned in the how do we integrate and find the solution, we have learned it. So like the variable separable method, when you are applying that, we need to integrate on both sides now. When you are integrating on both sides, y by 1 plus y square, we are going to get integration of 1 by x into variable separable, sorry, by parts method. Whenever you are partial fractions, not by parts. Okay, partial fractions, it is in the form of the x plus 0 into x plus a into x plus b. Partial fractions when you are using, and the left hand side, whatever the integration is there, which is in the form of integration of f dash of x by f of x, which is equals to log f of x. Okay, right hand side is individually integration of 1 by x f of x 1 by x dx is used. See how it is presenting here. What the formulas we are using, that is written to you in the boxes separately. So when you are presenting your solution, if it is in that way, we are going to get the good impression. Okay. So next, the equation we are going to get it finally as 1 plus y square into 1 plus x square equal to. Actually, you may get doubts, sir. C square x square we will get now. C square we will get, and C square can be is considered as a constant. The next model is homogeneous differential equations. And which function is called homogeneous differential equation? Means whenever the function is given to you in terms of x and y, in the place of x you write the k x, in the place of y you write the ky. Both sides you function, f function and g function you observe. Okay. And here f function, whenever you are taking into consider, you are going to get some k square into f of x comma y. But g function, whenever you take g k power 0 into g comma f, means k is eliminating. Okay. So in this, which homogeneous functions, when you are able to write in this form, means some constant, or whenever you are taking constant to the power of some number into that function, whenever you take, right, if it is able to write in that form, it is called a homogeneous. The power whatever you are going to get, it decides the degree of the homogeneous function. So the given function is f of x comma y is equals to 2x square plus x by x square plus y square, means in that situation 2x square, 2 is written side and y by x. So we can write this in the form of x square into f of y by x. Second function, whenever you take, you can write it as y power 0 into g of x by y. X by y is written here, y by x is written here. When you are taking common, both are in the same way here. Whenever you take into consider, f of x comma y is written as x square. So such type of the functions are called homogeneous. A differential equation in the form of dy by dx is equals to f of x comma y is said to be homogeneous if f of x comma y is a homogeneous function of the degree 0. Function is called a homogeneous function. Differential equation means differential equation is called homogeneous if the function is homogeneous function of degree. Function separately, whenever you take, it may be the homogeneous function of different degree, second degree, third degree, depending upon the constant. Okay, but if the function is there along with the differential equation, in the differential equation, and that differential equation is said to be homogeneous if the given function is homogeneous function of a degree 0. That means dy by dx should be, means we need to get the some constant substituting in the given function, means given function constant, if you are substituting k in the place of x, kx in the place of y, usually we substitute y is equals to vx. When you substitute y is equals to vx, y by x is equals to v. So differentiating on both sides, dy by dx is equals to v into x by. This is the procedure of solving the homogeneous differential equation. V plus x dy by dx is equals to x power 0 into h of v. So we are going to get v plus x into dy by dx is equals to h of v. So again, variable separable method can be applied here whenever you take. See here, 1 by h of v minus v into dv is equals to 1 by x into dx. So now again, variable separable method is applied here. When you apply the variable separable method, you are going to get the, by replacing v by the y by x, we are going to get the function, required function in terms of the solution of the differential equation, homogeneous differential equation we are going to get. Suppose in case the given function is in the form of y power 0 into x by y, we need to replace x is equals to vy. Just let us see this example. This example will give you the clear idea regarding the homogeneous differential equation. How do we get? When you take the x square common in the both numerator and denominator, we are going to get x power 0 and y by x. Yes, now this is a homogeneous differential equation. And to solve this homogeneous differential equation, we need to take the y is equals to vx. When you take y is equals to vx, we are going to get dy by dx is equals to v into x plus dv by dx. Okay, v plus x into dv by dx is equals to, when you are resubstituting that values in the given in differential equation, we are going to get the an equation in terms of the v and x, and this v and x will be transformed to again variable separable method. See here, all the v's are together, so that's why that v whatever we are having is transformed to left side. And now you need to apply the different methods what you have learned to do the integration for this. So whatever the methods we have learned for the differentiation, here it is given to you. The numerator's degree is lesser than the denominator degree in the left hand side. So completely it is interlinked. When you know the integrations properly only, then you can solve these problems. So integrations, all integrations are involved at the last step of the differential equation solutions. Last step it is involved. So all that, if you know that all the methods of integration only, then it is possible to you to solve this all in a proper way. The solutions are a little bit lengthy solutions, you may get it, but whenever you are taking here again resubstituting a v place y by x, we are going to get the required differential equation solution we are going to get it. This is a method of finding the solution for the given differential equation. Did you get my point? Any doubt here?